Okay, good morning once again, and you're on to Mamu with Jarvis. This is our grade 9 experience in the matter of algebra. This morning we'll be looking at a topic called simultaneous equations. Simultaneous equations, that will mean that I'm not dealing with one equation. And at your level in grade 9, we'll be dealing with two equations. How do we deal with two equations together? Simultaneous will suggest that I'm handling two things together, or I'm handling some things such that I expect the outcome to meet at a point. So when we talk about simultaneous equations, a key word that comes to mind is a matter of what is called a word that is called pair. Pair, which means we'll be dealing with, at your level, two equations such that we want to obtain the values of two unknowns. We're dealing with two equations, the concept of pair. We want to obtain two values for two different unknowns. So simultaneous equations will certainly worry about us obtaining values for two unknowns. These equations we are dealing with are essentially what? Linear equations. I don't know what your background on equations are, but a simple linear equation will be like, say, y is equal to x plus 4. That's one. And then I can also have that y will be equal to 2x plus, let's say, 3. So the first is a linear equation. The second is a linear equation. And our task in this course is to try to obtain values for y and x by solving them together. There are different methods to solving simultaneous equations. I'll talk about 3 methods. Hope I'm spot on that. The first method is what we call what? Methods of solving simultaneous equations. Notice I'm very emphatic on the plural. The first method is what we call elimination. This is my favorite method. Elimination is my favorite method. The next one is called the substitution method. Technically, this substitution method is even present when you're using elimination method. But in my take on this course, I will do a little tweak in the explanation. And the last one is what we call the graphical method. We can actually solve simultaneous equations by graphical method. Now, when I take you on this graphical method, I'll take you a little higher than what you've done, what you usually do in your JS3 experience, and bring a bit of the SS experience, and try to see how we will connect with previous knowledge you had gathered in geometry in the matter of a straight line. Maybe you've not done that in maths. Perhaps in your basic tech, you'd have been taught what a straight line is. We said a straight line is the distance between what? 2 points, which means to draw any line, I need just to know about what? 2 points. When we come to graphical methods, we're going to be playing with ideas. We won't follow the normal classroom approach. We're going to play with ideas and help you open up your mind to the concept of this topic we're considering. So, our textbook of reference for this course will be our New General Mathematics for JS3 grade 9. And we are on page 128, chapter 4. What I do when I take this course is this. I usually don't, what's the word now? I usually don't go with the method of the textbook. I start by using my elimination method. So you will notice that I wouldn't go with, I wouldn't talk about the graph because the graph, I wouldn't go with the graph because the graph is a separate method of its own. Yes, I got what he said. The graph is a separate method of its own. And then there's also substitution method, which has its own unique approach. but I will start off with the elimination method. So to kick off with that, I want us to go to page 133 and exercise 14D will be the reference point for me to work with. Exercise 14D, page 133 and 134. Exercise 14D will be what I'll be working with. All right, so I'm going to go with elimination method, but I would pick ideas from other aspects too. So I'm using elimination method, but I want us to look at exercise 14C. I'll be picking questions that will help drive the concept gradually to you, because I need to drive the concept gradually to you. So go to exercise 14C and let's start. That's on page 132. So we have a question on the board. We have a question on the board that requires us to solve the simultaneous pair. To solve the pair of simultaneous equations, we have x plus y equal to 3 and x plus 2y equal to 5. This is what I call the standard format of simultaneous pairs or pair. A simultaneous pair will usually have this format. So take note of it. Just as we had in equations, we keep the unknown on the left-hand side, or the unknowns on the left-hand side. I will keep the known on the right-hand side. So how do we solve this by elimination? We start by ruling a line, knowing well that the concept of elimination means that I don't want something anymore. So to use elimination, I look at the question I have. What don't I need? What don't I need? Hold on, please. We said that we keep the unknown or the unknowns on the left-hand side. I will keep the knowns on the right-hand side. The knowns will suggest numbers. The knowns will suggest what? Numbers. So with that said, we go into solving it. Elimination means that I want to remove what I don't need anymore. Elimination will mean that I want to remove what I don't need anymore. I have x, I have y. I can only remove one per time. I can only do what? Remove one per time. If you look at equation 1, I have x here. Look at equation 2, I have x here. Look at this, I have y, I have 2y. It will be easy for me to remove x than to remove y. If I remove x, I'll be left with y. So what do? I'm going to eliminate. How do I eliminate? The sign of x here is positive. The sign of x here is positive. So I will eliminate by subtraction. And if I subtract, x minus x will give me 0. So I don't need that. Y minus 2y will give me negative 2y. Now, because I got negative 2y, I can now do backwards. You know, in your primary school, you were taught that it has to be top minus bottom. No, there's no rule that says you must do it that way. You can say bottom minus top. The most important thing is what you do to one, you must do to all. So I will apply that concept and say 2y minus y, that'll be y. And I'll go ahead to say 5 minus 3, and that'll be what? 2. Maybe I should write again, because sometimes it's quite challenging to see the concept. This is 2y minus y. This is 5 minus 3. Assuming I'm using bottom minus top. So this will now be y equal to what? 2. Once you get this answer, you will then substitute. So I will say put y equal to 2 in this or this. In your classroom environment, you've been taught to say equation 1 and equation 2. I don't do that anymore. It's not relevant. So I will say put y equal to 2 in. I want to use this one. X plus y equal to 3. So with that, I'm going to have that x plus 2 will be equal to 3. And that will mean that x will be equal to 3 minus 2. What is 3 minus 2? x will be equal to 1. So solving simultaneously, we now have x equal to 1, and we also have that y is equal to 2. And that clears out the first problem. Okay, so we're done with question 1. We go to question 2. We have y equal to x plus 1, and x plus y is equal to 3. Now, for this question, we've said before that to use the elimination method, we keep the unknown on the left-hand side, and we keep the known, which are the numbers, on the right-hand side. So the first thing I need to do is to rescript this so that it's close to what I want. So I'll pick this one out. This will be y. I'll pick y equal to x plus 1 out. I've wrote this line to say that I want to work on this. This will simply be what? X plus 1 equal to y. And I can rearrange this to become what? X minus y equal to 1. Once I've cleared this, I can rule another line here. This is what I want to get, and I bring this one down. So once I get this now, I can now go ahead to solve the problem. Now, in this setup, you discover that the coefficients of x and y are the same. Look at x, 1, 1. Look at coefficient of y. Now, forget about the signs. Forget about the sign. Just imagine you're seeing whole numbers there. It will be 1, it will be 1. Now, in this setup, I can eliminate either of x or y. I can eliminate either of what? X or y. Now, if I choose to eliminate y, I will add, because the signs of y are different. So you can choose to eliminate y, and you can eliminate x. Whichever one you want to do is fine. But in this setup, I want to eliminate y. I've chosen to eliminate y. Y is negative here, y is positive here. If I have and I don't have the same thing, it means it will just be 0. It makes no difference. Somebody wants 5 naira and I'm willing to give 5 naira. It will mean that nothing has happened at the end of the day. So I will simply put an addition sign here, say that I've added, and this will be what? 2x equal to what? 4. Remember that because I'm just starting, I will break it down. This is x plus x. You wouldn't do it like this in an exam, but just to help us understand what's happening. This will be 1 equal to 1 plus 3. So this is 2x equal to 4, and x will be equal to what? 2. Once you've done that, you know that I'm always rolling lines of put x equal to 2 in. I can go back to this original one. Y equal to x plus y. And what does that give us? It will mean that y will be equal to what? 2 plus 1, meaning that y is equal to 3. So we have solved for x, giving us 2, and y equal to 3. So these are some of the variations you can have in solving these problems. Now, for this question, look at it. It's arranged for us. We have the unknown on the left-hand side. We have the known on the right-hand side. Now, which one can we eliminate? You discover that for the numerator for the first equation and second equation, the coefficient of A are not the same. For B, they are technically the same, because when we say the same, we're not looking at the sign. We're looking at whether the whole number coefficient is the same. This is 2. This is 2. So I can perform elimination here, but I cannot perform elimination here. So in this question, I must eliminate what? B. All right. So I'll rule off. And how do I eliminate B? This is negative 2. This is positive 2. I eliminate negative and positive by adding, and I eliminate negative and positive by adding. But if they were both positive, I will eliminate by what? Subtraction. If they were both negative, I would eliminate by also subtracting. So for this, I will eliminate by addition. So I'll put a plus here. This plus this will give me, I'm still writing it out, although in an exam you need not write this, but just to show you what's happening, I have eliminated this. And this will be what? 14 plus 14. This will now give me 7a equal to 28. And if I divide both sides by 7, a will be equal to 4. I will rule this off. The next thing I do is to say put, because I've got a and I need to find what? B. So I can use equation 1 or equation 2. Please, if you notice something here, I've taught you reduce to the lowest. You notice that you have 2a, you have 2b here, you have 14. Please resist the temptation of trying to want to reduce, dividing through by 2. It's not relevant in this question because what the objective is to try to eliminate. So with this, we put a equal to 4 in. Now, when I'm putting in any of the equation, as much as possible, avoid the coefficient of what you are looking for to be negative. So this will now be what I'll say in what? 2a plus 2b equal to 14. So I'll write this one out. This 2a plus 2b equal to 14 can be the same thing as a plus b equal to 7. How? They are all numbers I can divide through by 2. I take care of that first. Then I make my substitution of a equal to 4 in here. 4 plus b equal to 7. And b will be equal to 7 minus 4, which means that b will be equal to 3. So my answer, b will be equal to 3. So at the end of the day, I have a equal to 4 and I have b equal to 3. And that takes care of the solution to that problem. Okay, in our next question, question 4, we're going to observe that elimination goes beyond being able to identify what can be eliminated. Sometimes you have to force the elimination process to occur. You have to do what? Force the elimination process to occur. How do you do that? Now, we borrow from a simple concept we had learned previously, and that's a matter of LCM, lowest common multiple. Now, if you look at the coefficients, there's no way I can eliminate anyone. 3 minus 2 will give me 1. 2 minus 3 will give me something negative. So there's no way I can eliminate any one of them. So what do? I look at this one. What will be the LCM of 3 and 2 to be 6? What will be the LCM of 2 and 3 to be 6? Now we have a situation where the LCMs are the same. So I can use any one. So for me, in such a setup, I would advise to use X to try to do what? Eliminate what? X. So how do you do that? Now, the LCM is 6. What must I multiply to 3 to get 6? It will be 2. So I put times 2 here. What must I multiply to 3 to get? I multiply to 3 to get 6. It will be 2. To multiply to 2 to get 3, and to get 6, it will be what? 3. So I'll generate new pairs of equations, new pairs, or a new pair of equations rather. So this will now be what? 6x. These two will multiply everything. 2 times 3 will give me 6x. Okay, so 2 multiply 3 will give me 6x. 2 multiply negative 2y will give me negative 4y. 2 multiply 4 will give me 8. We go to the next one. 3 multiply 2x will give me 6x. 2 multiply 3y will give me plus 9y equal to 3 multiply, or rather 3 multiply 2 gave me 6. 3 multiply 3 gave me 9. And 3 multiply negative 6 gave me what? Negative 18. Now at this point, we can now eliminate what? This. How do you eliminate? Now, please, I want to make a very solemn appeal. You're going to eliminate by subtraction. And this is where you have to be very, very, very careful. Now, there are 2 ways I can go here. But let me go with what a lot of students might be comfortable with. Now we're trying to break away from this top minus bottom. But let's assume I have students who must do top minus bottom. So this will be negative 4y minus 9y minus this will be equal to what? 8 minus negative 18. So let's be careful. Let's be very, very careful when we work this one out. 8 minus negative 18. This is this minus this. This negative must affect each of them. This is what I'm eliminating, so it will be 0 automatically. So this becomes negative 4 minus 9 means you are doing subtraction. That will be negative 13y equal to 8 minus becomes what? Plus 8 plus 18. That will be negative 13y equal to 26. Now, at this point, I always tell my students, be careful when you have negative as a coefficient. Sometimes we just say divide by negative 13. I'm usually not comfortable with that. If your bad side is equal to your good side, it means your good side. If my bad side is equal to your good side, it means that my bad side, if my bad side is equal to your good side, it means that my good side must be equal to your bad side. So quickly swap that. It's not a very good practice to be dividing by negative. So that means that y will be equal to negative 26 divided by 13. And y will be equal to what? Negative 2. Now, having done this, I will now put y equal to negative 2 in any of these equations. Any of these. So I could say in what? I always tell my students, avoid where you have, okay, I can put it here because the coefficient of x here is positive. It's best that way. So I'll say in equation 1. But if you put in any of the equation, you still get the same result. In 3x minus 2y equal to 4. So that will be what? 3x minus 2 into negative 2 equal to 4. Meaning that 3x plus 4 will be equal to 4. I got that right. And invariably 3x will be equal to 0, which means that x must be equal to 0. Now there's something else we should learn when we solve equations. It's also very important to test whether what you have done is correct. I went for a kind of work and I got the greatest horror of my life there. Sometimes it's good to test. I know I teach students not to bother test. If you've done the right thing to, it is okay. But once in a while, it's also good you test. So if we're going to test, x equal to 0, y equal to negative 2. Negative times negative is positive. Fine. X equal to 0. 3 times negative 2 is negative 6. So that means that answer is correct. So with that, I have that x is equal to 0 and y is equal to what? Negative 2. So that solves that question. Okay, we've done 4 questions, and what we'll try to do is to look at different ways elimination method works. Different case scenario, what you need to do, how you need to study it from not doing anything to doing something more technical to be able to study the equations so that you can eliminate. Now, if you look at this one, look at this one you have on the board. You make a very interesting observation, or you'd have made an interesting observation. Now, watch the second equation. You have 2u plus 7v equal to 3, which means that the order we want is what? U and then v. You have v here, you have u here. So I have an issue here because I have some of the terms. I have one term here, I have another term here. So I need to rearrange this. So I'll start by saying 5v is equal to 11 plus 3u. I'm going to rearrange this. I'm not going to rewrite 11 plus 3u equal to 5v. Now, because the order of my second one is u and then v, I will then go ahead to say 3u minus 5v is equal to what? Negative 11. I've done 2 movements now. I've taken care of this, and I've taken care of this. So essentially they were positives, so they will now become negative. So this is what I'm expecting to have, or I'm expected to have. And then I will then reorder the equation. So I'm going to have 3u minus 5v. Let's bold them out. 3u minus 5v equal to negative 11 as my first equation now. And then 2u plus 7v equal to what? 3. Now you notice that the coefficients of u are not the same. Same thing as the coefficients of v, they are not the same. So looking at it straight on, I can't do any elimination, but I can do something. I can force an elimination by looking for their LCM. Now, look at this. 3 and 2, the LCM will be what? 6. 5 and 7, the LCM will be what? 35. The rule here is that you eliminate the term or you eliminate the unknown with the least LCM. That's the advice. Let me not say the rule, the advice. Because I know students who want to go, but the general advice is that eliminate the one with the least LCM. So 6 and 35, which is bigger? 35 is bigger. So I don't want to go towards 35 because it might be a little difficult for me to work with. So with that said, I'm going to eliminate u by using LCM of what? 6. So what will I multiply 3 by to get 6? It will be 2. What will I multiply 2 by to get 6? It will be what? 3. Okay. So that's done. I'm going to generate new sets of equations now. These two will multiply everything here. So I'm going to get 6u minus 10v minus 22, 6u plus 21 equal to 9. So how would you eliminate now? I'm going to eliminate these two by subtraction. So I'll put a minus sign there because they are both even. I mean, they are both positives, so I can eliminate them. Now, this will be negative 10v. Sorry, there's supposed to be a v here. Negative 10v, yes. Negative 10v minus 21v. I told you that when you are solving, you don't need to write this, but I do this so that for those of us that may not follow the process correctly, we know that that's what is happening. This will give me negative 22 minus 9. So this will be what? Negative, negative means I'm performing addition. So this will be negative 31v equal to what? Negative what? 31. They are both negative, means that if negative is equal to negative, it means that their positive sides are equal. So I will simply say 31v equal to 31. It's not necessary for you to say divide both sides by negative, no. And this will now be v equal to 31 over 31. You may not even do that. Since the coefficient are the same, I can just go ahead to say v is equal to 1. And it's clear. Anybody saying that knows that what you have done is correct. Once you are done with this, rule this off. You now put v equal to 1 in either this or this. So I can use this. I would say, I can say in, I want to use this. May not be the best, but I just want to use this. 5v equal to 11 plus 3u. So this will mean what? 5 times 1 equal to 11 plus what? 3u. So it means 3u plus 11 will be equal to 5, and 3u will be equal to what? 5 minus 11. So what does that mean? It means that 3u will be equal to negative 6. And if I divide both sides by 3, it will mean that u will be equal to negative 2. So what do I have? I have v equal to 1, and I have u equal to negative 2. The order in which you write the answer will not matter. What's most important is that you've indicated the answers. And let me also tell you something. In an exam setup, once you've gotten your v and your u, you do not necessarily need to tell the examiner this anymore. The examiner has cited it and he will award you your full marks for citing that correct answer, except where in some exams like Cambridge or whatever, where you are expected to put your answer in a particular place provided for you. All right, so that's that for the elimination method. So with these 5 questions I've answered, I've been able to extract all the possibilities you can have when it comes to the matter of simultaneous equation solving by elimination method. In our next meeting, we will go into solving simultaneous equations using what is called the substitution method. It's not different from what we've done, but just that you start substituting from the beginning. That's why it's called substitution. You would have observed that even in elimination, you're using substitution. Every elimination method will end in substitution. But I can also teach you how to solve pure elimination without substituting. But that will be for another class. So thanks for your time. And I'm going to give you assignments as is my practice.